All right, everybody, welcome back. Today we are going to sketch the graph of polynomial functions. Specifically, we're going to pick a couple good x values, plug them in, and evaluate our function to get some points. And then we're going to use end behavior to kind of make a smooth connection between each of our points and get a rough idea of what this polynomial is going to look like. So the first thing I want to do is I want to pick some good x values. Although you can really pick what you would like, there are a couple things we want to keep in mind. So first of all, we're going to want some positive and negative numbers so we get either side of our x-axis, either side of our y-axis, in our graph. All right, I'm also going to pick smaller values. All right, if I pick a larger value, plugging it in and evaluating might give me a larger output, and that might make it harder to graph. Realistically, that just makes my job harder, which is not what I want to do here. So I'm going to pick some small x values here. -2, -1, 0, 1, and 2. Some people like to only use 3 values, so such as these x values right in the middle, which is okay, but with 5 we get a little bit more of an accurate representation of what this polynomial is going to look like, so that's kind of what I like to do. So what I'm going to do is I have each of my x values, and I am going to evaluate the function f of x for each x value. What that means is, let's say I want to find f of -2. Well, what that means is I'm going to take my function and I am going to plug in -2 for each of my x's. All right, we can go ahead and simplify that, and we end up getting a +3 out. So that means the point -2, +3 is a point on our polynomial function. Now I'm going to do the same thing with -1, 0, 1, and 2. And when I do that, I get out -4, -3, 0, and -1. And that's really just using the same process that I described over here, except I'm just shortening it a little bit to save some time. So now I'm going to graph those points. We have -2, +3, -1, -4, 0, -3, 1, 0, and 2, -1. All right, so now all we really have to do is connect our points in a smooth curve. So starting anywhere, I can flow through one point into another, and then kind of continue that trend. And that last line at the end there didn't look great, so I'm going to redo this. It's going to look something like this. Now, it might not be perfect. We might actually go through the x-axis and then back down through here and go lower and then back up, and there might be other curves. We don't have all of that information at the moment, so this is why we call it a sketch. It's a rough estimate and idea of what it should look like. Now, we also got to remember that we can do end behavior. As x approaches infinity, our function f of x does what? As x approaches -infinity, our function f of x does what? So all end behavior means is as x goes to infinity, well, it just means on the right side. What is our function doing on the right side? Well, you can see we've got an arrow pointing down. That means the function goes towards -infinity. And then if we take a look at our left side, as x goes to -infinity, our function is going up towards +infinity. Well, we got that from the graph. Let's not forget that we can get it from the equation as well. We need to look at two things. First of all, we need to look at that degree. The degree is the highest exponent, and in this case, it is 3. And we also need to know what our leading coefficient is, and that is the coefficient in front of the variable with the degree. So in this case, it is -1. So the 3 is an odd number. When our end behavior is odd, that means, when our degree is odd, that means our end behavior is going to be opposite, which is why we have one positive and one negative. All right, odd means opposite. So we've got the opposite, but then we also have a negative leading coefficient. So what I typically like to remember is when that coefficient is positive, our positive infinity should line up with a positive infinity. Our negative should line up with a negative. They kind of match that way. And again, they're opposites because our degree is odd. Now, when our coefficient is negative, what that means is these are going to flip. So it's no longer going to be positive to positive and negative to negative. instead, and let's just rewind a little bit here, we end up with this. Positive to negative, negative to positive. So that causes it to flip-flop. All right, so that kind of coincides with what we got from our graph. So that means we have a pretty good sketch of what this polynomial function is going to look like, and we are done. Now, we are going to do the same thing over here with a function we call g of x, which is x to the fourth minus x to the third minus 4x squared plus 4. Now, let's start the same process. What I want to do is pick some good x values, so I will pick the same ones as before, -2, -1, 0, 1, and 2. Again, those are my go-to. I think they're probably the easiest ones for us to use, and they include both positives and negatives. And then I need to evaluate my function at each of those values. So that means I am going to plug in -2 for each of my x values. When I do that, I get out 12. And unfortunately for us, that is off of our graph here. So that's going to be, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, something all the way up there. So not the greatest point for us to use, but we should get some better values when we plug in -1, 0, 1, and 2. So when I do that, I get out 2, 4, 0, and -4, which I can go ahead and plot. So -1, +2, we have 0, 4, 1, 0, and then 2, -4, which is right there. All right, so before we connect these points here, why don't we do the end behavior? So our end behavior, again, focuses on two things. We've got our degree, which in this case is 4. So before, when we were looking at our degree, it was 3. 3 is odd. Odd means opposite. Well, now our degree is 4, so if odd is opposite, even should be the same. So what that tells us is our end behavior, as x goes to infinity, to the right, our function g of x is going to do what? And then as x goes to -infinity to the left, our function is going to do what? So in this case, our end behavior, these two values right here should be the same. Either they're both positive or they're both negative. Now, let's just say I make them both positive for now. The next thing we need to look for is our leading coefficient. And in this case, our leading coefficient is 1, which is positive, which means there are no reflections and everything gets to stay pointing up. All right, so when your degree is even, your end behavior, these two values, need to be the same. Odd means opposite. Odd, opposite, even, same. All right. When that leading coefficient is positive, that means both of them are going to go up towards positive infinity. And when it is negative, they would both go down towards negative infinity. Now, if I just keep that in mind, well, let's just say before I just connected these, I might end up with something like this. But I know that I need to end up going back up somewhere, all right, because we need to go up in both directions. So if I didn't have my end behavior here, if we didn't find that, our graph probably wouldn't be that accurate. We have an arrow pointing all the way down. And again, it might look a little bit different. We could look something like this. Could be more in there. All right, all we're doing is going off of the few points that we have and our end behavior. So this is going to be a pretty good sketch for us, okay? So that is how we do end behavior and graphing, sketching the graph of polynomial functions. It really takes a little bit of work, plugging in some values, evaluating functions, and looking at that end behavior, but then it should be pretty straightforward for us. All right. So one of the last things I want to do is sketch a graph of a function with the following characteristics. So these problems always seem challenging because you're given a lot of information, but the key is understanding what information you are being given. If you can figure that out, it really shouldn't be all that complicated. So if we take a look, the first two key characteristics, it says g of x, so that's our function we're going to sketch, is increasing when x is less than 0. So just for now, I'm going to put a line here, and we should be increasing for all values less than 0. It's going up. All right, and then we're also going to increase for all x values greater than 4, which is right there. Well, without even reading the second line, if we know we're going up outside of these values, it's probably a safe assumption, and we can see by looking at the next bullet point that we will be going down in between. We are decreasing between 0 and 4. So our first two bullet points are really just talking about when we are increasing and decreasing, when we are going up and down. So as you can see, I drew these lines, which I'll erase later, but it kind of tells me what parts I should be going up through and what parts I should be going down through. Now, the next point, the next two bullet points, say when g of x is greater than 0 between -2 and 3, and then after 5. We are less than 0 or below the x-axis when x is less than -2 and between 3 and 5. So what we're doing is we're describing the values where we go from being above the x-axis to below, or vice versa. Those values are -2, 3, and 5. So if I just take those, well, the values, the points that we call where we are going from below the x-axis to above are x-intercepts. All right, so I'm going to plot those points. We get -2, we've got +3, and then +5. So really what we should be doing is we should be going up through those points, right? Because up through this point until we hit that line. And once we hit that line up top, we can see we need to start going down through the next until we hit the next line, and then we will be going up. So it's going to look something like that. All I'm going to do is pick a spot and start filling through until I hit that line, and then I'm going to curve back down again as my arrows up top are telling me. So now I just hit the line here, so I need to start going up through that next point, and I'm going to finish off with something like that. Now, let's go back to these values. We should be above the x-axis between -2 and 3. Well, we've got -2 and 3, and all of this is above the x-axis. And then when x is greater than 5, we are also above. So that fits. All right. So realistically, the first two bullet points are telling us where we're going up and down. The next two bullet points are just telling us our x-intercepts, and then we kind of combine that information to make a smooth curve through each of those points. So again, this isn't the only option. We could have a polynomial function that was much more steep, but as long as we are meeting the characteristics where we are crossing through the x-axis at these values, and we are decreasing between here and increasing everywhere else, it works. And you know, the key to this is in the directions. It says sketch the graph of a function with the following characteristics, not the function. There are lots of different options. Yours does not need to look exactly like mine. It could be much more shallow if you wanted it to be. It could be much more steep if you wanted it to be. As long as we are meeting those characteristics, we are good to go. All right, so that is all we have for today. Thank you for sticking around to sketch the graph of polynomial functions. As always, if you have any questions, please feel free to leave a comment, like the video, and subscribe, and enjoy your evening.